Hey everybody, thought I'd give you some help on quiz 1B. I think this is question number 1 in your quiz, and it says, crackers come in packages of 24, cheese slices come in packages of 18. You want one cheese slice for each cracker. What is the least number of crackers and cheese slices you can buy so that nothing is left over? When you see this word least, then that's kind of a big clue that we're probably going to need to find the LCM of the two numbers, which are 18 and 24. So if we start using prime factorization as our technique, that's probably going to be fastest. So how about we do like a 2 and a 9 here? And then if we keep branching on the 9, we might get a 3 and a 3. And then we'll bring down the 2. Over here, we might do a 3 and an 8. And then here, how about a 2 and a 4? Bring down the 3. And how about here, we'll do a 2 and a 2. And we'll bring down the 2 and the 3. All right, so if we do one of those Venn diagrams to help us organize our thinking, we're going to have this circle represent the prime factorization of 18. We'll have this circle represent the prime factorization for 24. And we'll put all of our matches where the circles interlock. So let's look for our matches. We'll use a different color. How about red? All right, so we have matching 2s. Let's put that in here. We have matching 3s. Let's put that in here, squeeze it in. We have, that's it, that's a match. So now everything else goes on the outside. So we have a 3 here. Let's put that over here because that's part of the 18 tree. And then we have a couple of 2s, so we'll put that here. All right, so to find the LCM, the next step is going to be to multiply the numbers that we have together. So we have 3 times 2 times 3 times 2 times 2. So if we chunk these up, how about we chunk up this 3 and this 2 is 6. This 3 and this 2 is another 6. And then we have this 2. All right, so if we do 6 times 6, that gives us 36. And if we do that times 2, we add a room there. Let's see if I can move that out of the way. Here we get the 12. See, I'm running out of room there. Well, I'll just try to squeeze it in. This would give you 6 and the 1 more is 7. All right, so we know that the LCM is 72, even though it's hard for you to see on my screen. Now, how are we going to use that to answer the question? Well, we kind of need to know this is how they come in packages, right? So we're talking about total cheese slices and crackers. So now it's just a question of figuring out how many packages. So take the 72 and divide it by 24 to get what we need for crackers. Take the 72 and divide it by 18 to get the number you're going to need for cheese slices. And that should do it for you. All right, good luck finishing this question up. Let's look at another one. This one says, a lumberyard worker is cutting 3 tree trunks into equal sections. So I'm just going to put the number 3 above there so we remember. The tree trunks measure 28 feet, 14 feet, and 42 feet. If the sections are as long as possible, how long should each section be? So long kind of goes along with greatest, right? Greatest. We could rephrase that as greatest. And we've been talking about when we see that word in a word problem, that we probably need to find the GCF of the numbers that are in the problem, which in this case are 28, 14, and 42. So that means that we probably would want to find the prime factorization of all 3 of those numbers. So we would branch on the 28, we'd branch on the 14, and then we'd branch on the 42. And in class, we talked about if you suspect a number as being the GCF, then you should put that in the lineup of all of your factor trees. So I'm thinking it might be a 7. So I'm just going to put a 7 in all of the factor trees. And then we have to think about what would the other factors be in each tree. So over here, I'll use a different color. Over here, this would end up being 4. Over here, this would end up being a 2. And over here, this would end up being a 6. All right, now because it looks like these green numbers will share some common factors. That means there actually is a number that would be higher than our suspected one of 7. So we can't conclude that 7 would be the GCF, and therefore we should continue with our tree. So let's keep branching on the 4. And these are prime, so that tree is done. And let's keep branching on the 6. And we'll bring down the 7. All right, and bring down the 7 here as well. All right, so when we do our Venn diagram, this time we need a triple Venn diagram, which is going to make this a little more tricky. So let's see where do we have room to put it. I guess I'll try to squeeze it in over here. So this circle will represent our prime factorization for 28. This circle will represent our prime factorization for 14. And then this circle will represent our prime factorization for 42. And anything that's in common in all three, we're going to squeeze in here where the 3 circles interlock. So let's look for those numbers. Let's look for a triple, what I call a triple whammy match in our prime factorization. So here we have a triple whammy 7. So let's put it in here. And we have triple whammy 2s. So let's put it in, squeeze it in there as well. All right, now that's all that's a match. If we were interested in the LCM, which we're not, then we would take this 2 and we would put it here. We'd take this 3 and put it here. We're interested in the GCF, so we're going to multiply those numbers that we have in there, 7 times 2, which is going to give us 14. All right, so the GCF is 14. The GCF is 14. Now let's just make sure that that's what they're asking for, because recall in class, sometimes we've had to multiply that by some stuff. So reread it again and see if we need to somehow use distributor property. And if you don't think we need to use distributor property, you might be completely satisfied that that's the answer. And if you are, then you're going to go ahead and pick letter choice C. Let's look at another question, shall we? A movie theater has 250 seats. 3,250 tickets were sold at the theater last week. How many movies were shown at the theater last week if every person who bought a ticket saw a movie and every seat was filled for each feature? So basically we need to figure out how many equal groups of 250 are there in 3,250. So when you go to set this up, we're just going to do the standard algorithm. Let's get the black pen going here. You're going to set up the standard algorithm. So this will be your dividend, 3,250. And this will be your divisor. Now, if we look at the answer choices, in each case, they're talking about using the number 1 as your first digit. So let's make sure we understand where you would put that 1. So 250 does not go into 3, nor does it go into 32. So we're going to look at it into 325. So what you're going to do is you're going to try, since each choice is suggesting 1 as the first digit, you're going to try the 1 and subtract and see what happens. Now, when you subtract, you're going to get a number left over. Make sure it's less than 250. And then bring down that next 0 and figure out whether the next digit is a 1, a 3, a 5, or possibly 130. All right, good luck finishing that one up. All right, so let's look at this question, because I just want to point out one thing. I'm not going to go over too much about this because you should be in pretty good shape with this. It says Mr. DeLuca had $568.34 in a bank account. How much money did he have left in his bank account after he used his debit card 2 times, each time for $27.50? So what I just want to remind you about is that he used it 2 times. So we need to find out what 2 times this number is first. Find what 27.50, which is the same thing as 27 5/10, I might add. What is that when you double it or times it by 2? Now you're going to come up with some answer. That won't be the answer because they want to know how much money did he have left. So you're going to take that value and you're going to subtract it from this, and that will be your answer for number 5. All right, so this question, it says, this is question number 6 on your quiz, so we're kind of jumping around. The distance around the outside of Cedar Park is 0.8 of a mile. Joni ran 2/500ths of the distance during her lunch break. So if we kind of picture that, so let's say that this circle kind of represents the trail, and the whole trail is 0.8 of a mile. And if she ran this much. That's like a quarter of it, right? So let's say the starting point was here. A quarter of it might be, like maybe right here. That's 25/100ths of it, right? We have to find of usually means multiply. So if you multiply this number times this number, that should get you the answer. So we're going to take 25/100ths and multiply by 8/10. And you don't need to be concerned about lining up the decimals with multiplication. So you'll do the standard algorithm, and then don't forget at the end, you have to move the decimal over 1, 2, 3 to the left. So once you get your product, move that decimal 3 to the left, and you'll see one of the answer choices as your answer. All right, let's take a look at a few more. This one you should be in pretty good shape. You're just going to be dividing. Zoe earned $28.38 working for 3 3/10 hours. How much did she earn per hour? You're taking this value and dividing it by this value. So just a couple of quick reminders. When you divide, don't forget we have a decimal divisor here. So that means that before you start, you need to clear the decimal by multiplying both of these by 10. So if we multiply this by 10, that's essentially moving the decimal here and making that number 33. And if we multiply this by 10, that's going to move this over here. So when you put your decimal in your quotient, it's going to go between the 3 and the 8, right there. So just be careful with that. And I would recommend taking your answer that you choose and multiplying it with 3 3/10 to make sure you get 28 3/800ths, or $20.38. All right, so number 8 says, a one-celled organism measures 32 millimeters in length in a photograph if the photograph has been enlarged by a factor of 100. So that means we had this small picture and we multiplied it by 100, and that gives us the actual length of the thing, right? The actual length. Let's go back and look at the numbers. So it measures this much in the photograph. If the photograph has been enlarged, so if this is what it is in the photograph, and we're enlarging it by a factor of 100, that means we're taking that number and we're multiplying it by 100. So just finish that up to get the actual length of the organism. Now remember, multiplying by 100 is the same as adding 2 zeros or moving the decimal 2 to the right in the original number. All right, number 9 says, you can buy 5 t-shirts at Baxter's for the same price that you can buy 4 t-shirts at Bixby's. If one t-shirt costs $11.80 at Bixby's, how much does one t-shirt cost at Baxter's? So let's read it again to make sure we know what we're talking about. So 5 t-shirts at Baxter's, right, for the same price that you can buy 4 t-shirts. So we know that one t-shirt at Bixby's is this. So if we take this number, I'm just going to leave the 0 off just because it's an easier computation. If we multiply that number by 4, right, because we're talking about if one t-shirt costs $11.80 at Bixby's, right, we would probably want to know what is that times. We have to figure out which one of these numbers to multiply it by, right, to figure that out. So this is one we should probably read it one more time. You can buy 5 t-shirts, so let's keep track of our 5 at Baxter's is going to equal 4 at Bixby's. So 5 at Baxter's is equal to 4 at Bixby's. And we know that one t-shirt at Bixby's, this is for 1 at Bixby's. Forgive my... See, we need to figure out what that would be times 4, right? Because that's for 1. So if we multiply these two numbers together, that will be how much we're spending for 4 t-shirts. Now, since they're saying it costs the same to buy 5, now you need to use that number to figure out where to go with the answer. So I think if I give you too much more, then I'm actually going to give you the answer. But you're going to go ahead and the first step is to find this product and then read it again. All right, so let's take a look at number 10. It says the men's world record for the high jump is 2 45/100 meters. A puma can jump about 1 9/10 times as high. What is the height a puma can jump? So as you're thinking about this question, ask yourself, who can jump higher? Is it the world record for a man? Or is it the puma? So if you're saying the puma is going to be jumping higher, then that means that you would be multiplying these two numbers together to get the puma number. But if you're saying, no, I think the man can jump higher, then you're not going to be multiplying. You have to think of another operation. All right, so good luck with that one. That's all I'm going to tell you about that one. And I think that's it. So good luck finishing up your quiz. I'm going to recommend if I went a little fast, it's a good idea to replay this, pause it, write the notes down in your notebook. Just, do the best you can. And if you have other questions, make sure you reach out through email to both myself and Mrs. Verdero. All right, good luck.